Okay, so now what we're going to be doing is looking at trigonometry and finding exact values or finding the angle, but instead the angle is not going to be in degrees, or we're not going to be using degrees. We're instead going to be using radians or finding radians. On top of that, we might have just barely touched on this, but we're not going to be simply looking at sine, cosine, and tangent. Instead, we're going to be looking at the reciprocals, or the flip of, and we're going to be looking at cosecant, secant, and cotangent. So we're going to be looking at 6 different trig ratios. Now, don't get too caught up in this, but I would like just to show this. So let's say our angle was down here. Now we did this, in grade 10, grade 11, but sine of an angle, this angle, sine would be opposite. This is always the adjacent, and the hypotenuse is always the longest one. Okay, so I guess we don't even know what this hypotenuse side is. You have to do a squared plus b squared equals c squared. Now you can do the a squared plus b squared equals c squared, but that's really not the point. You end up getting, 289 or something square rooted, which is 17. So back to the question, sine theta. So sine theta is opposite over hypotenuse, which is 8 over 17. And we did some of that before. Therefore, you can see here, sine is going to be, cosecant. Well, I should move over back here. So the reciprocal of sine, which is 1 over sine, is cosecant. So cosecant, you can see instead of opposite over hypotenuse, it's hypotenuse over opposite. It's flipped. So cosecant, when we solve for these, cosecant of theta is not 8 over 17, it's just simply 17 over 8. So we're going to flip it. Now cosine is adjacent over hypotenuse, so it would be 15 over 17. Now the reciprocal of that is secant of theta, and that's just the flip of this, 17 over 15. And lastly, you've got tan of theta. Tan would be opposite over adjacent, which is 8 over 15. But then you can have the cotangent of the angle, which is going to be 15 over 8. So the only thing I really want you to get out of this, because we're not going to be doing questions like this, the other thing that's really important to know is that these things just get flipped. Okay? So let's take a look here at that special diagram that we had to draw. We're going to do it again. Except this time, we're going to be doing this with radians. I'm trying to draw a relatively straight line here. So this is going to be 0, and this is going to be pi, because 180 degrees is the same thing as pi. And then back here, if you double that, you're at 2 pi, because 2 pi is all the way around. So you need to remember 2 pi all the way around, pi halfway around. Half of that, so if this is pi, what's half of that? Well, that's pi over 2. So if this is pi over 2, and you have this, that would also be another pi over 2, and then this would be another pi over 2, for a total of 3 pi over 2. So we're no longer going to be thinking of this in terms of 90, 180, 270, 360. Instead, we're dealing in radians, so pi over 2, pi, 3 pi over 2, 2 pi, or 0, depending on how you start it. Now, if you cut this in half, this is pi over 2, and you cut it in half, you're at pi over 4. The same thing as 45 degrees. And then these ones right here, remember how we had those? This one right here was 30. That's going to be pi over 6. And this one's going to be pi over 3. So these ones just have to be memorized. You can do the work. You can say, okay, well, 30 degrees. I want to turn it to radians. I got to get rid of degree symbol, so I'll put it down here. Right? This is how you convert to radians, so the degree symbols can cancel. So you have 30 pi over 180. Those can both be divided by 30. So that gets you pi over 6. So down here, pi over 6 is the same thing as 30. So sometimes it's nice when you actually draw these to, if you wanted to, you could write 30, 45, and 60 just as a reminder to yourself. And I've just memorized it that the pi over 4, the 4 for 45. It would have been nice if the 3 went here, and here the 6 went here, but they're backwards from each other. So The 30 was the pi over 6. The 60 was the pi over 3. And of course, these were your 90, 180, 270, 360. So you can have both, but the idea is you're supposed to be dealing with these fractions. Continuing on here, we've got the way we counted this. I'll make this a little bigger here. You start on the right-hand side, and you go 1, 2, 3, and then down 1, 2, 3. So the rest of this is all the same. Cut them in half. The only thing that was changing was these radians and degrees. And then you can square root the tops. And of course, over on your sides, you've got 1, 0, 0, 1, negative 1, 0, 0, negative 1. And remember, you could put a little star here or something. It's cos of the angles on the left, and sine is on the right. The last thing is the tangent. It's the sine over cos. Remember, tan of theta is sine of theta over cos of theta. So in this case, it would be 0 over 1. 0 over anything is 0. In the top here, it's the right over the left. So 1 over 0. You cannot divide by 0, so it's not possible. On the left here, it's going to be right over left. So 0 over negative 1, which again is 0 divided by anything, is 0. And then here, right over left again, negative 1 over 0 is not possible. You cannot divide by 0. So I'm just writing all of these. These are all my tangents. This one is going to be right over left, so 1 over root 3. This one is root 2 over root 2, which root 2 over root 2 is just 1. And then here you've got root 3 over 1, which will just be root 3. If you want to know what happened to the 2's when I divided them, you can go back and watch the very first video in this chapter, and I did go over that there. Now 1 over root 3, generally we don't like the square roots, so we're going to rationalize, but I'll leave it like this for now, and we can rationalize that if it gets to that point. So that's what our graph looks like. This will help us when we're solving questions. But these are the only things that are new. So keep that in mind. Everything else here is the same. So that will be it for this video. And then in the next video, we will actually use this stuff.